Hello again. This doesn't actually belong in the radical or exponential form problem, but somebody actually asked in the forum why, when I did this particular type of problem, it came out as it did, as opposed to what they anticipated in a former lesson. And you know, it was a pretty good question. I thought it warranted an explanation, because I don't know if I explained it as well as I probably should have. I mean, I obviously did it right, but you know, when they did it, they thought it came out as a different sort of answer, and they couldn't understand why. And they couldn't see the differentiation between them. So I'll go ahead and explain that. Square root of -6 times the square root of -10 is a very interesting problem, because what happens is these are both imaginary roots and you have to solve accordingly. Now the first thing you're doing when you're working with radicals that happen to be negative and they're under a square root, or they're under an even root in general, I guess is probably the way you can say it, is that you have to compensate for the imaginary value. You have to basically pull out I. So what I'm trying to say is this: if it's negative square root of 6 times negative square root of 10, what the person had done was, oh, I'm just going to use, you know, the radical property of multiplication, and -6 times -10 is 60. Well, that's actually not correct, and here's why. And I'll go ahead and do this problem in just a second and show you why the answers don't come out consistently. So the square root of -6 is actually I root 6. You pull out a -1, the square root of -1 is actually I. So it's I root 6 times I root 10. Now what you can do is you can split the numbers accordingly. You know, 6 goes into 2 and 3, circle your primes. 10 goes into 5 and 2, circle your primes. I times I is I squared. 2 times 2, when they're both outside, becomes a 2. You know, you're pulling out 2 of a kind. They have to come out in pairs. So, bam, pull out a 2. And then I have a 3 and a 5 left over, so they don't have their partner, so they have to stay inside. That's 15. I squared by definition is -1. And I did a whole series of lessons. Well, not a whole series, just this lesson on that. So you can look over that if you want to for complex numbers. So -1 times 2 times root 15. -1 times 2 is -2 root 15. That's your answer. It's -2 root 15. It's not, you know, 2 root 15. No, it's not that. It's just -2 root 15. Now, if you went ahead and you tried the problem multiplying before pulling out the i's, what you're going to get is square root of 60. That actually is not correct. The reason, very simply, is, okay, I'm going to split this up. 15, 4, 5, 3, circle your primes. 2 and 2. 2, neither of those have a partner, it's square root 15. This is our answer. This isn't. Bam. When we're working with radicals, I personally like splitting them up. I think that students find it very favorable. Comparing it to factor trees, fantastic. But the first thing that we ever have to do before we apply any sort of property, and that includes multiplication, quotient, etc., is we have to pull out i's if the radical is negative. So if it's square root of a -6, you have to pull out the I first. That's a given. That's actually, you know, the law that precedes all other laws in terms of quotient and product, etc. So I thought that was a pretty interesting lesson to show. I hope that you found it informative. Don't do it like this. Always pull out the i's first before you do anything else. Other than that, have a good day. Goodbye.